Good morning and welcome to National Science Week 2020 here at the Queen Victoria Museum and Art Gallery in Launceston, Tasmania. I'm Martin George. With me is my colleague Chris Arklis. Together we run the Launceston Planetarium, where we introduce thousands of people to the wondrous sights of the night sky. This is the first of 7 live stream events we have for Science Week 2020. We'll be having a session at 10 o'clock every morning on YouTube with various topics that we'll be talking about. Always remember that you can post your questions online and we'll be answering those later on in the session. This morning, we're going to be speaking about Tasmania's night sky. And to start off, I'm going to hand over to Chris. Over to you.
Thanks, Martin. Yes, on this rather damp morning here in Launceston, the wonders of technology will allow us to view our night sky, indeed our daytime sky, from the lovely sunny summit of Mount William in the far northeast of Tasmania. And why have we got that? Can you go back to the... we're going to have to open the PowerPoint when it comes due. Try now.
Yes, we didn't really mean to take you back to the 17th century there, but we'll hand back over to Chris.
Can you no, just a sec, I'll get rid of all of them.
So while Chris is doing that, certainly we have a wonderful view of the night sky from here in Tasmania. It's absolutely terrific, as long as, of course, we have a nice clear sky. And we always have one on the computer. So we'll hand back over to Chris.
Thank you. Try this time. That looks a lot better.
There we are.
So here we are, as I mentioned, the sunny summit of Mount William in Tasmania's far northeast. One of our more humble mountains, only about 216 metres high, but it does offer a beautiful view, panoramic view. We're looking to the northeast there with the sun and the moon. We'll talk about the moon again in a moment, but we'll give a quick spin around the view out to the Tasman Sea, then looking off to the west, and we're back, looking north again. You can see the moon there. The moon is up at the moment. It's coming up to new moon tomorrow, when it will be pretty much in the same direction as the sun. It's not tomorrow, Monday. It is Monday, isn't it? No?
I think it's Monday coming up, yeah.
But we don't want to be looking at the daytime sky for too long. Let's move through to the evening. So we'll just speed time up a little. So you can see the sun is appearing to follow the moon across the sky. And we'll talk a little bit more about that a little later on. As the sun heads down towards the horizon, we start to get our sunset, and as it heads further below the horizon, we start to see some of the brighter stars appear. There's a couple of other objects that we'll be seeing as well very shortly. Start to see a few of the brighter stars there now. We'll just enjoy the last of the sunset to give us a better night sky. And as the final bit of the early twilight fades there, we'll now pan around back to the north east. And we've got two particularly bright objects above the horizon there. The brightest is the planet Jupiter, and below that we've got the ringed planet Saturn. Now, even with a pair of binoculars, it is possible to see the 4 largest of Jupiter's moons appearing as small dots adjacent to the planet. We can zoom in here on the software A bit like using a telescope, we need to keep adjusting our angles as we go in, as we magnify the sky more. And another problem that we have with real telescope viewing is, of course, time. The Earth is spinning, we're all moving around the sun. The beauty of a computer is we can stop time so things won't move out of our frame. So we'll move in a little bit closer. And there we can see Jupiter and some of its moons. And I'll just bring up.
Takes me back to when I first used my telescope on Jupiter. Isn't it great?
It is a good view. And you can see that in Jupiter's moons are all nicely lined up. This is only the brightest of the moons. Jupiter's got quite a collection of moons. How many?
79 at last
79
count,
at
actually,
last
yeah, but
count.
only 4 are bright enough to be seen in binoculars and small telescopes.
If I turn the orbits on, we can see how the moons are all orbiting around Jupiter on pretty much the same plane. Now that will become quite relevant a little later on in our discussions this morning. So if we zoom back out, and we have a quick look at Saturn. Now, unfortunately, your binoculars, unless you've got a very, very good pair, are not really going to give you much of a view of Saturn. But a telescope certainly will. And we can simulate that here with our software. Now, Saturn, of course, we thought that Jupiter had a lot of moons. Saturn, I think.
Last count is about 82, I think.
82.
It's the leader.
And again, if we were to turn our orbits on, you can see that they are all pretty much in line with each other. The angle between those orbits and the Earth and Jupiter's orbits, Jupiter was more side on at the moment, but remember, all these planets are orbiting around the sun together with us. So we see things at different angles at different times. Anyway, let's zoom back out and have a look at some more of the sights that we can see this evening. Still pretty early, still about 6:30. Now, if we were to look almost directly overhead, we can see one of the more, I'll get rid of those star names, they're somewhat distracting. We can see a pattern here. Some quite bright stars that make quite a distinctive pattern. This is Scorpius, the scorpion. Now, this bright star in the centre there, that is Antares, the brightest star in Scorpius. But we can bring up Scorpius's outline. You can see his claws there, his tail, a little stinger on the end. Quite a big stinger on this piece of artwork. Scorpius is one of the famous constellations because it is one of those that the sun passes through. There's 88 constellations altogether, official constellations in the night sky. Of course, this is just the official ones. Other cultures have lots of other constellation stories, and not all from joining up the dots of the stars either. Some using some of the dark patches. We can actually see some dark patches in the Milky Way in the background there. This is the band of light of the Milky Way. Would you like to comment about some of those dark veins, actually.
Yes, indeed. And this is something that you can see far more clearly if you're well away from those nasty city lights. When we look up to the Milky Way, at first we feel that we're seeing a general band of light up there, a fuzzy band of light crossing the sky. But from the dark country skies, we see that it's interrupted by dark dust lanes. They look like gaps in the Milky Way. And going right back to the early 20th century, even as little as just over 100 years ago, many people wondered whether they really were gaps in the starry nature of the Milky Way and that we were seeing through to empty space. But the astronomer Edward Emerson Barnard really worked out that they were dust clouds interrupting our view of the brighter parts beyond. And it's great to see those from the dark country skies.
Now, I mentioned that Scorpius was one of the famous ones because the sun passes through them. We can see the other 11 of that group stretching across the sky there. Now, as I say, they're just a subset of the official constellations, and they're the ones that the sun passes through. And the sun actually travels along a line that we call the ecliptic, which I can show here. But there's a little problem. If we zoom back in towards Scorpius, we can see the borders around these constellations. There we are, zooming in towards Sagittarius. Come back, there's Scorpius. Unfortunately, the borders are not showing up as well as we might like at the moment. But you can see that there is a gap through here where the sun is outside the borders of these constellations. There is a constellation there, and it's one of the larger in the sky. It is Ophiuchus, the serpent bearer. Now, you had a couple of stories about Ophiuchus.
Yes, indeed. At the planetarium recently, we've had quite a few questions about this constellation. It's been mentioned that it's just been discovered. Well, actually, it hasn't. We've known about Ophiuchus, the serpent bearer, the pattern that looks like a man with a serpent, for a very, very long time. Of course, these constellation patterns are all imaginary, but this particular one was also known even as long ago as the Babylonians are watching the night sky, a very, very long time ago. So nothing new has been discovered. Perhaps it's that many people around the world are discovering, in a sense, that the planets don't move specifically through the main 12 constellations that so many people know so well.
That's quite right. And remembering back to when we were looking at Jupiter and Saturn and the moons orbiting around on pretty much the same plane, we can see that Jupiter and Saturn, they've now been joined by Mars. They are all also along this line, very close to it. Mars has drifted away a little bit, and Martin might comment on that in a second. But the solar system, this line is effectively Earth's orbit around the sun. The solar system, much like those moons orbiting around the other planets, is basically a flat disk with all of the major objects orbiting on the same plane. Would you like to speak about Mars being away from the line there a little?
Yes, indeed. Not all of the planets are orbiting exactly the same plane as the Earth. That line that you mentioned a little while ago, Chris, called the ecliptic, is actually the plane of the Earth's orbit in space. So that's the plane that the sun seems to follow exactly. But yeah, the planets follow much along that same plane, tilted a little bit by a few degrees here and there. And that means that they're not always exactly along that line called the ecliptic. Mars is tipped up a couple of degrees, and that means that from here on Earth, we actually see Mars being a bit sort of above or below the ecliptic most of the time.
Of course, that same effect, above or below the ecliptic, is why we don't get eclipses of the moon every full and new moon. Normally, it will be above or below the line.
Indeed, that's right. So that's why eclipses are so interesting to watch, and we have to watch out for when they're going to happen.
Indeed.
And the moon's orbit too is tilted as well, so that makes it rather complicated.
It does. Now, we've talked a little about Mars, so we should zoom in on Mars, have a little quick look at that, and then Martin, I think you're going to talk a little bit more about Mars.
Yes, there's been a lot of interest in Mars lately, Chris. So there we are, zooming in toward Mars, known as the red planet. More of an orangey red than a red, but of course that colour is really easy to see just with the unaided eye. You don't need binoculars or telescopes to identify that wonderful colour of Mars.
And again, we need to stop our
So
time.
we're seeing what happens there when you look through a telescope.
Indeed.
It looks like it's moving because we are.
So we've stopped time for the moment. One thing I will say about the software, we can see two of Mars, well, the only two moons of Mars that we know of. And they look quite large there. They are very small moons. How small? Only tens of kilometres.
That's right, yes, 10 or 20 kilometres across, yes.
The software, of course, has to plot brightnesses for different objects to make them visible. And to have a nice realistic view when we are further out, once we start zooming in, these figures we need to adjust it, and we haven't have got time to adjust everything on the fly. So these moons at this distance from Mars would be still virtually invisible, I would think. Well, not invisible, but to the naked eye, but they wouldn't be as bright as we're seeing them there.
They're actually very hard to see, even through quite a good telescope. Even though the telescope was invented in the early 17th century, these moons were not discovered until the year 1877, when an American astronomer named Asaph Hall noticed them through quite a powerful telescope.
Now, if we just change back to the PowerPoint, I'm going to have to start again. That was our problem at the beginning, trying to get the computer to do too many things. They're not as clever as they...
Yeah, so we will take you back to the 17th century, first of all, because I'd like to speak a little bit about what's happening with the Mars missions at the moment. Going back to the invention of the telescope, or not long after it, we can see that people did realise that there were some markings on Mars, and there were white polar caps and so on. This is one of the earliest drawings by an astronomer named Christian Huygens. And in the 19th century, the famous astronomer Giovanni Schiaparelli in Italy became very famous when he observed Mars through this wonderful refractor telescope, the type of telescope with a lens at the front, and he drew lines across the surface of Mars on his map. These are now known to be optical illusions, but Schiaparelli called them canali, which in Italian implies that they are channels. People thought he meant canals, and that's how the story of the Martian canals came about. But we have discovered with our modern spacecraft that there was indeed once flowing water on Mars. It's not there anymore, at least not flowing. So Mars has definitely changed. We think there were oceans and lakes on Mars, and it's a topic of major study at the moment. We've had many spacecraft go to Mars. We'll just go through a few of them. Here's one called the Mars Global Surveyor that operated quite some years ago and took some great images of Mars. Mars has some global dust storms from time to time, which even make it hard to see the features with our telescopes here on Earth. The Mars Odyssey spacecraft, that's still working, made a discovery that there was ice within a few centimetres of the Martian surface just underneath. The Mars Express, the European Space Agency craft, is still orbiting Mars. We also have the best mapping craft ever sent to Mars, the Mars Reconnaissance Orbiter. This is a NASA mission, and that is still in orbit around Mars after 14 years. The very first pictures we had of the surface of Mars came from the Viking 1 spacecraft on July the 4th, 1976. when the United States had its first successful landers there. And in more recent years, we've had the Mars exploration rovers on Mars, a couple that arrived in 2004. They had a planned mission time of about 3 months. They operated for many, many years. And currently, the mission that's operating on the surface is the Curiosity, or one of the missions, I should say, the Curiosity rover. And now, to give you some idea about those wheels on the Curiosity rover, here's a shot of me taking a look at a full-scale model of one. So they're actually quite large wheels, and they need to make sure there's enough traction to move across that Martian surface where the dust is as fine as talcum powder. But recently, there's been a lot of talk about missions to Mars. 3 have just been launched, one from the United Arab Emirates on a Japanese rocket from Japan very recently. It's going to be in orbit around Mars and study the Martian atmosphere, the Martian climate, I should say, and the Martian weather. We've also had the launch of a Chinese mission to Mars, which is taking up a rover, and here's a model of that one, and also an orbiter to make a lot of studies of Mars. And we've also seen the successful launch of the latest NASA mission to Mars from the United States, the Perseverance rover, which is going to be making a lot of studies basically looking at ways in which humans can live on Mars. One of the experiments is to produce oxygen from the Martian atmosphere, which is made mostly of carbon dioxide. And the thing that fascinates me at the very most is this. It's the first helicopter ever taken to another planet, the Ingenuity helicopter. It's going to be making some 90-second flights in the atmosphere of Mars as a test before NASA builds bigger and better helicopters in future. These can scan in front of the rover and tell the mission controllers what's ahead and which way to steer it. So a lot of excitement about those missions to Mars at the moment.
Just a little comment about the helicopter. When I first saw images of it, I was struck by the resemblance to Galileo's early drawings of hypothetical helicopters.
Yeah.
Da Vinci, sorry.
Da Vinci, that's right, Leonardo, indeed.
Yeah. And it's sort of almost poetic, the similarity.
Yeah, it is actually. This is a very little one though, of course, Chris. It's very small indeed. It weighs less than 2 kilograms and it needs to be pretty light. It's a test of the technology. Those rotors have to spin at about 2,400 revs per minute to gain enough lift in the very thin Martian atmosphere, which is only about 1% the density of Earth's. So it's pretty tricky to fly a helicopter on Mars. I'm really looking forward to seeing what happens with that one.
Thanks. Now, just a little technical question. You have another slide or two. They were for later.
They're for later on, yes, when we talk about some other objects in the night sky. So maybe we can switch back to your night sky output at the moment.
We can see if we can do it without too much. I think we're going to have to close it.
Okay, Chris will reboot that. But don't forget, everyone, when you look up toward Mars tonight, that's if it's clear, you can think about those missions that are on their way. It's a real challenge to send spacecraft to other planets, and not all of them have succeeded. Several Mars missions in particular have been lost, and Mars is notorious for the proportion of missions that have failed. So let's hope that these go well. Currently, the news is pretty good. So if Chris is ready to return to the night sky, I'll hand back to you.
We will in a moment. I'll just get us to a reasonable time of the evening. We're going to be looking south in a moment, and that's not a bad time, round about 8 o'clock this evening. In fact, what we will do is we'll go through to just before midnight. So if we bring up...
Hopefully you're all up at midnight to have a look at this, but let's hope it's clear. We've had some comments online that it's pretty rainy today over Tasmania.
Not on Mount William. Not on our digital Mount William anyway. Okay, so if we go back to the to our view, we can have the looking to the south. We've got a mark there, which I didn't really want there just yet, but we'll talk about it now. These stars here are the Southern Cross, and we can show the outline of the Southern Cross there. Oops. That's better. The Southern Cross, and above it, we've got two bright stars, Alpha and Beta Centauri, that we also call the pointers. Now, to find south with the cross, what we need to do is imagine a line from the top of the cross down, or in this case, up through the base, and project that out into space. We need another line from halfway between the pointers, come out at 90 degrees, and where they meet is very close to this point, which you won't see in the real sky, but we can mark here in our software, the South Celestial Pole. That is the point in the sky directly above south on the horizon. And as the night progresses and the Earth rotates on its axis, you can see how this geometry continues to work. The stars continue to point towards the celestial pole. So the Southern Cross and the pointers, and if we look up here, we can see these couple of smudges of light. They're the so-called clouds of Magellan, or Magellanic Clouds, whichever you prefer. We've gone through to dawn. Let's just wind time backwards a little. The Magellanic Clouds are actually other galaxies external to the Milky Way. They never set from Tasmania, and back in 1987, there was an event in the Large Magellanic Cloud, which Martin will talk about. But what we'll do is change our time to just before midnight. It'll do. Get ourselves into...
A reminder, of course, that these faint things in the sky you see much better from the country. If you're in the middle of the city, I'm afraid you wouldn't spot the Milky Way, and you certainly wouldn't spot the Magellanic Clouds. So those people who live out in the country are at a great advantage.
So that is the Large Magellanic Cloud as we would see it on a good, clear, dark night at the moment. But in 1987, it didn't look quite like that.
So I can remember that night very, very well, Chris. A friend of mine rang me and he uttered one word, supernova. I'll never forget that. Actually, I think the large one is the one down the...
I've lost it.
Lower down at the bottom? Yeah. Good thing the sky doesn't appear to really do this sort of thing, otherwise we'd be in real trouble.
I've got myself lost, as you do sometimes with a telescope.
There we go.
Is that it? No?
Down near the bottom, I think. There you go. That's the one.
Well, we haven't got it. Oh, I know why we haven't got it. I haven't got the date quite right.
Yes, you won't see this thing now. You'll see the Large Magellanic Cloud, of course, and the small one. But way back in 1987, there was something rather special that happened there. And as I've mentioned, my attention was alerted by my colleague who uttered the word supernova. And while Chris is setting that up, a supernova is an exploding star. And there are two types of these. One that in which the core of the star collapses, and there's an enormous explosion that blows most of its material out into space. Another type is a white dwarf star that only has a certain maximum mass, and when more is tipped onto it, it basically just goes bang. But in 1987, one of these core collapse supernovae appeared in the Large Magellanic Cloud. That's not our galaxy, that's another galaxy, of course, one of the two nearest galaxies to our own Milky Way galaxy. But it had been a very long time since we had seen an exploding star without having to use a telescope. The most recent one was in 1604, 383 years earlier, when the famous astronomer Johann Kepler observed a star where one had never been seen before, and that was in our own galaxy. But this particular one was in the Large Magellanic Cloud. So we're ready to zoom into that one, Chris? Okay, I'll pass you back over to Chris for this.
So that is the cloud as it appears at the moment. Actually, in February, this is where I was going wrong before, to get it to appear in the same point in the sky, of course, it has to be the same time of the year. February at the moment, if we go back now to 1987, and significantly different. A new, very bright star there.
Amazing.
And we can actually zoom in on that. And that is the supernova, and we can see, actually in 1987, if we did zoom in, it wouldn't have actually looked completely like this because, well, but that's a good question. This material, a lot of this material is shed from that star.
Some of it, not the material we're seeing in this particular simulation right now, Chris, but when you take a time exposure picture of the night sky, the camera shows up a great deal more than we can see with the naked eye. Obviously, the supernova is the brightest point of light in that picture, the brightest single point of light, and that was really obvious to the naked eye. But long time exposure photographs show up nebulae, clouds of gas out there in that galaxy, and star clusters. There are a lot of star clusters in the Large Magellanic Cloud. And that particular cloud of gas that we see just above the supernova is called the Tarantula Nebula, because some people think it looks a bit like a tarantula. To astronomers, it's known as NGC 2070. And you can see it with a pair of binoculars.
So, Supernova 1987 is back in the news again.
It is indeed, and I have a couple of shots there, Chris. If we can move back to my PowerPoint, what's happened recently?
Back over to the PowerPoint.
Yeah, if we can swap to the images that I've got, and in a few moments, folks, we'll wrap up this session and see if we've got some questions. But if we take a look at the images that we've got, which Chris is just setting up, basically the reason it's been in the news so much is that when astronomers observed this star exploding back in 1987, they realized that it was likely to produce either a neutron star or a black hole. That core collapses in on itself. The more massive stars produce black holes, but this one was expected to produce a neutron star. Unfortunately, astronomers hadn't been able to detect its presence for quite a long time. They've been looking for pulses from it, thinking it would become what we call a pulsar. But in recent times, they've actually discovered the strong evidence that the neutron star is actually there. Let's take a look at a picture that, first of all, that I've taken of the Large Magellanic Cloud, very similar to the one, Chris, that you showed a little while ago. And we'll move on to a picture that I took. This is a real photograph showing the location of that supernova in 1987. I took this shot from dark country skies well away from Launceston. But more recently, this is what we're seeing. Now, this is a rather complicated looking picture. Early on, there were eruptions of material coming from this star before the main supernova explosion that's being illuminated in this picture as a ring around the supernova location. But if we zoom in on that central section there, as you can see, there's a warm cloud of gas. And a lot of analysis has been done on this. It's been detected using an array of radio telescopes called ALMA in northern Chile in the Atacama Desert. It's a cloud of gas that's glowing at a temperature of about minus 240 degrees Celsius. That's not much warmer than what we call absolute zero. But it's at the right temperature to show astronomers that the energy of the neutron star, it would be illuminating that cloud of gas or heating up that cloud of gas to about that temperature. So for the very first time, we've seen this strong evidence. It's been confirmed this year that that's the likely cause, and it's allowing astronomers the opportunity to make early observations of a neutron star not long after formation. Of course, when I say not long after formation, it always fascinates me and our planetarium audiences that all this happened 168,000 years ago, because that's how long the the light has taken to get here. So we're really looking back into time. Not that that matters to astronomers. They're seeing it as if it were happening now. Wonderful stuff, isn't it?
It is. And that is interesting. We were going to talk, and we're running out of time, we were going to talk about distances and the time that light takes to travel. But one other quick comment about the images of the supernova there. Some observant viewers may have noticed that in my stellarium images taken from Mount William, the supernova was towards the top of the Magellanic Cloud, whereas in the other images it was towards the bottom. That is not that it's in a different spot, it's just the nature of our telescopes. When we're looking through telescopes, we forget about up and down in space. The optics of the telescope move things around virtually randomly, not randomly, but depending on the angle of the eyepiece to the angle of the telescope itself, things appear in different positions.
We have a couple of questions online, Chris, that we might move to. We've had a question as to whether we're in the planetarium. Actually, we're not, but we're not far from it. We're here at a studio specially set up for Science Week here at QV Mag. And this is where we'll be, not Chris and I on all the days, but we'll be we'll be having our live YouTube presentations from this room here at QV Mag here at Inveresk in Launceston. We have a question also about how the Milky Way was formed. Well, astronomers think that basically galaxies formed out of building blocks of smaller clumps of material a very long time ago. Of course, the universe is changing and galaxies have been building up from all of this material. We currently think that there are about 200 billion galaxies in the universe. Actually, we've only really known that there are lots of galaxies for about the last 100 years or so, because up until that time, astronomers thought that our galaxy was the only one, and that these wonderful spiral shapes that could be seen through telescopes were spiral clouds of gas. But Edwin Hubble, the famous astronomer after whom the Hubble Space Telescope was named, noticed that in actual fact, these objects are very, very distant. He made special observations with a telescope in the United States to show this. And he realized that, in fact, we are just one out of many, many galaxies. But there are other kinds of galaxies. They're not just spiral galaxies. We also have elliptical shaped galaxies, the Magellanic Clouds, which are largely what we call irregular galaxies. And we've also discovered in recent times, relatively recent times, that most galaxies seem to harbour a black hole in the middle, and even our own too. And all of this information can help astronomers to learn more about how galaxies were formed in the first place. But as I've said, certainly the universe is changing, the galaxies are evolving, the universe is getting bigger and bigger as well. That's another topic that would take a long time to talk about. Maybe we can do that at another stage. Just checking to see if we have any more questions. What's the current thinking about how the moon was formed? Okay, well, actually, it's a great question.
A good ad,
right now,
a good ad for our new show.
It is. Right now in the Launceston Planetarium, one of our regular shows is called Birth of Planet Earth, which also talks about how the moon was formed in a rather spectacular way. Astronomers think that the moon was formed when the still forming Earth was hit by an object about half its size, in other words, another planet. And that planet doesn't really exist anymore. It's been named Theia. And the whole idea was that billions of years ago, this object called Theia collided with the Earth, and the resulting collision produced a great deal of debris that ended up in orbit around this still forming Earth and gradually came together to form the moon. Actually, astronomers for a very long time had been wondering how the moon could have been formed, and this sort of scenario seems to fits the formation of the moon best. But there had been ideas that the moon formed when a piece simply came off the forming Earth. There have been questions about whether the moon could have already existed in the solar system and been captured into orbit around the Earth. That's actually a very hard thing to do physically. Most things would just simply fly past. So that's how we think the moon was formed.
Although in Mars's case, it's quite likely, is it not, that some of its moons are captured asteroids?
Indeed. In that case, there is the idea that they are captured asteroids. And in fact, they really do look rather like asteroids. If you look at close-up pictures of them, they are very, very small indeed. But yes, in answer to the question about how the moon was formed, that's the current thinking. And how many years until we live on Mars?
Just before we go on to living on Mars, another interesting bit of advertising we can do with the question on the moon. We have got our broadcast or our live stream of the tides coming up next week. And the moon is, of course, critical to that discussion.
Indeed. So we'll be talking a lot more about the moon a bit later on in the week. Just going back to the most recent question, how many years until we live on Mars? That's something that so many people ask at the planetarium, isn't it, Chris? The answer is I really don't know. But one of the fascinating things there is that, well, both Chris and I were around at the time of the Apollo landings on the moon. And when Neil Armstrong and Edwin Aldrin were setting foot on the moon way back in 1969, they were thinking that we'd have people on Mars by 1983. And that sounded so futuristic then. I can remember thinking, wow, do we have to wait that long? Well, we are getting there in a way. As I've mentioned, the Perseverance rover is going to be carrying out some experiments that will help human habitation on Mars by producing oxygen from the Martian atmosphere. We're learning more about the water on Mars, its history and so on. But sending people to Mars is a huge undertaking. Well, that was a bit of a long answer, and I still haven't mentioned when I think people will be on Mars. I'd like to think it's sometime in the 2030s, but I really think that's the most optimistic suggestion. It may be the 2040s or even beyond before we have people there. I certainly hope it's in my lifetime. I really want us to see and hear those transmissions from the first person to set foot on Mars. Wouldn't it be great, Chris?
That would be amazing, yeah.
Indeed.
Because the other question there is whether there's any life anywhere else. One of the main purposes of the current NASA mission heading there is indeed to see if it can find traces of or proof of previous life in mostly bacterial type things. But,
there could have been life there once in a very primitive form. We do have a couple of minutes left. We have a question. When will the sun expand into the Earth? Well, actually, yes, the sun will get bigger eventually, but it will be billions of years, probably about 5 billion years before the sun is large enough to actually have the Earth inside it. It will happen. At least the Earth will be very close to the edge of the sun, if not inside it. Gradually, the sun will age and it'll be fairly stable for a while, certainly in our lifetimes anyway, and for a very long time to come. But within about 1 or 2 billion years, the sun's energy will be so great that it's likely at that stage that there won't be oceans on the Earth. They'll have all evaporated away. But later, the sun will be a red giant, a very big star, and certainly will encompass the orbits of Mercury and Venus and probably the Earth, but don't panic at the moment. So we have, I think, another question. What attempts are being explored to convert the Mars atmosphere to oxygen? Yes, that's an experiment on board the Perseverance rover to take in some of the carbon dioxide of the Martian atmosphere. And it's a very small experiment. It's not designed to produce large quantities of oxygen, but certainly it's going to be necessary because when people live there, it'll be important to make use of those natural resources, including water on Mars, which is not in flowing form, of course, but is in the form of ice. And we do know that there is some of that underneath the surface. I mentioned earlier on that observation was made by, amongst others, the Mars Odyssey spacecraft way back about nearly 20 years ago, as a matter of fact. So we certainly do need to know a lot more about that environment on Mars before people can live there. But as I said, I do hope it happens in our lifetimes,
yes.
Chris. It'd be a great subject for the planetarium shows, wouldn't it,
would.
as well?
Yeah.
Yes. So we're about to run out of time now. This is just a 45-minute live stream. We might have one or two other questions on there that I'm afraid we don't have time to answer this morning, but certainly you can continue to put your questions online and we will attempt to answer those at a later stage. Thank you for coming along, or for joining us, I should say, here on our QV Mag live stream this morning. Don't forget, we have more to come. And tomorrow, we'll be talking with David Maynard, our Senior Curator of Natural Sciences here at the Queen Victoria Museum and Art Gallery, and also Dr. Beth Fulton, who will be joining us from Hobart. She'll be talking about the blue economy. So our subject tomorrow is going to be water on the Earth and on other planets. I do hope you can join us tomorrow. I'll say goodbye from me for now. And
Yes, and goodbye from me as well. And having had a preview somewhat of tomorrow's talk, I can guarantee it's going to be interesting.
Indeed.
See you then.